Howdy, my name is Dan and welcome to our ionic thruster demo. First up, the big question at hand. How do we move air without moving objects? We'll look no further, we have an ionic thruster, okay? So what we want to do first here with our big old magical project is we want to create a very, very high voltage. So we've done that with three separate components. Starting out from the wall, we have a wall adapter which takes the AC power from the wall and creates a DC 12 volt output current, a stable output, which we can put into our PWM module here, which takes that 12 volt DC stable output and creates an artificial AC wave, again, still at 12 volts, and puts it into our transformer here, which takes that artificial 12 volts AC and takes it and steps it all the way up to 3600 volts, okay? Still AC here, and we're getting very high, we're getting up there, we're getting to high voltage, but we're not quite there yet. Next up, we have our booster module slash rectifier module, which takes that AC current at 3600 volts and takes it to 36,000 volts direct current output. So now what we've done here is we've created a very, very high voltage between two very close points, and we want to create ions. We want to create ions to move air, but I'll let my partners here explain the rest of that.
So this is the ion thruster, and it's a little bit hard to see because of the funnel design, but what we have over here is a part attached like so, which holds the collector pipe, and this is the titanium plated steel blade. And when we attach these two together, and as you can see over here, there's a funnel type design. What happens is the electric field at the tip gets so concentrated that it literally rips apart electrons from the air molecules. And so what happens is these become positively charged ions. And as we know that charged particles flow from the positive side to the negative side. And what ends up happening is the charged particles end up trying to go to the other side, but there's still some neutral air molecules in the middle. And ultimately what happens is the ions end up pushing the neutral air molecules as well. You can imagine it as being, imagine yourself in a ball pit and you're just moving across, and what ends up happening is you end up bringing a bunch of balls with you. And what happens is that it ends up pushing the rest of the air through, and that's what the current is. And so what we're going to do is light the candle. Ooh, magic. The real show is about to go down. Let's see. And should be, there you go. There it is. It is also known as electrohydrodynamic thrust, but you can call it ionic wind. Yeah, thank you.
So we have another ionic thruster design here. With our first design, with it being horizontal, we were getting good airflow with it, but we thought that maybe if we can place the blades in a circular orientation, as we kind of have here, with a circular copper ring, we can maybe get some better airflow with it. And creating this prototype and testing it out, we were able to see that we did actually get some better airflow, and we can show that by blowing out these two candles here. As we can see, we actually do blow up both of the candles, and we can even feel that there's a lot better airflow with this new design, and we can even test that by moving the candles and just using the blade from this lighter real quick. So if I place this lighter here, we can see that already from this distance, the blade is creating more airflow. And now if I bring it closer, it'll be enough to even audibly hear it and then completely blow it out. Yeah. My name's Keyan Reza, and this is Think Deep, the Deep program.